Well, welcome everyone. I'm David Madison. I'm the director of NISS, the National Institute of Statistical Sciences, and a professor at Cornell University of Statistics and Data Science. This is our capstone web event for the NISS FCSM collaboration on AI and federal government. We're super excited about today's sessions. And I also want to acknowledge the organizing committee that spanned NISS and FCSM. It didn't come together without a large core group of volunteers. And one more shout out to our sponsors for this series, the ASA, NORC, and RTI. So with that, I introduce Bob Savinsky, who's our chair for today's session. Bob.
Thank you very much, David. I am very happy to be here. And as the chair of FCSM, I'm thrilled that this has been such a successful and well-received series, and I have high expectations for this capstone one as well. We have a great set of speakers here for you today. If you could go to the next slide for me, please. Thank you. All right. Yeah, I just want to take a moment to thank our sponsors, of course, for this webinar series. We're able to provide this entire series free of charge to many hundreds of attendees over the set of the series, and so we really thank these folks for making that possible. All right, next slide, please. All right, I will introduce our speakers very briefly and then give a little bit of framing for this panel itself, and then I will turn it right over to the speakers. I want to make sure that we have some time at the end for discussion with our group here. Okay, so Reva Schwartz is a research scientist in the Information Technology Laboratory at the National Institute of Standards and Technology, where she serves as the principal investigator on bias and artificial intelligence for NISS Trustworthy and Responsible AI program. Her research focuses on evaluating the societal impacts of AI systems, improving organizational practices, and driving understanding of socio-technical systems within computational environments. Her background includes a forensic science posting for almost 15 years with the United States Secret Service, a temporary duty assignment at the National Security Agency, and adjunct researcher at the Johns Hopkins University Human Language Technology Center of Excellence. She's advised federal agencies about how experts interact with automation to make sense of information in high-stakes settings. Our next speaker will be Kevin Tupper. He has over 20 years of experience in technology, spanning various sectors, including startups, corporate businesses, and federal agencies. His focus is on making technology usable and effective for organizations, a principle that he applies in his current role as Microsoft's federal Gen AI evangelist. In this capacity, Kevin educates federal agencies on the practical applications of generative AI and supports them in implementing this technology. Prior to this, Kevin led a team of cloud solution architects at Microsoft, focusing on providing federal customers with secure and efficient cloud solutions. He also worked directly with several strategic U.S. federal agencies, helping them leverage data and AI for optimal results. Kevin holds a record of bringing value in his previous roles as well, including serving as Chief Technology Officer for multiple companies, whether it's enabling millions of golfers to reserve tee times online or creating data warehouses capable of handling billions of responses. Kevin's expertise has proven beneficial across diverse applications. Kevin's talks are known for their straightforward approach, providing audiences with actionable insights on complex topics, all without the fluff. And our next speaker, Travis Hopp, serves as the Associate Director for Data Science and Analytics at the National Center for Health Statistics within the Centers for Disease Control. He leads research, development, and policy work on AI. Recently, his team enabled CDC to be the first federal agency to unilaterally deploy a generative AI model, ChatGPT, to all of their staff. Before his tenure at the CDC, Travis co-authored The Pile, a pioneering open source data set used for training large language models that served as a catalyst for promoting open science within the field of AI. He holds a PhD in physics from Drexel University and served 2 postdocs at the National Institutes of Health. He serves as the CDC representative for the National Science and Technology Council for AI/ML and is a standing member of the Federal Committee on Statistical Methodology. Finally, Stephanie Lee Studs is the Associate Director for Economic Programs, bringing with her over 24 years of experience in support of economic and enterprise programs. She oversees the release of over 100 indicator releases that come out monthly and quarterly as first measures of the health of the United States economy. Stephanie spearheaded the practice of smarter government by building a partnership between the Census Bureau and the St. Louis Federal Reserve to use their Fred mobile app when the America's Economy mobile app reached its end of life. She also expanded EID's efforts to use alternative data sources to supplement indicator surveys. She's been recognized for transforming data collection at the Census Bureau by being awarded multiple Department of Commerce bronze medals, as well as multiple Department of Commerce gold and silver medals. All right, so thank you to all of our panelists. They're going to be speaking in a slightly different order than you see them on the screen to keep all of you at home guessing and to make sure you don't go anywhere. If you could go to the next slide, please. So in general, this webinar series has, and I hope that this is, many of you, this will be not your first webinar. I hope you are enjoying these and coming back. Thank you, perfect. And previous sessions here provided insights for federal staff and supervisors at all level of experience with AI and explored cutting-edge AI enhancements that could be useful for agencies in implementing AI. And we talked about featured use cases at various agencies, and we also targeted webinars to focus on the examination of implications of AI for federal agencies, including issues of confidentiality and privacy, ethics, organizational challenges, managerial challenges. And as you can see from the title here, this last particular webinar, we're going to really be talking about organizational issues and challenges when implementing AI. So like I said, I want to be brief here and hand it over to our first speaker, who will be Travis Hopp, but I just wanted to say at the beginning, and we'll get into this more in our panel discussion at the end, I hope, if we have the time for it, but I want to make the distinction that when we talk about organizational barriers, that there are sometimes good barriers and less good barriers, and when we run into barriers in implementing a technology, it's worth the effort at the onset to think about the nature of the barrier and whether it's an appropriate barrier or not. So good barriers keep you from running off the road when you're driving your car on a mountain, right? So I think some of the presentations here today specifically are really going to be talking about good intentional barriers. And these can be valid guardrails for specific policy concerns like privacy or bias or equity or fairness. And these are barriers that can help us, when they're deployed properly, overcome other types of barriers that may be less productive. So if there are risk aversion barriers within an organization, then having these kind of intentional barriers in place can help us break through those. So I hope we all kind of, through this, keep that open mind that good barriers can help us actually in our mission to make sure that federal agencies are able to take advantage of opportunities. All right. And with that, I'm going to turn it over to our first speaker, Travis Hopp.
Thanks, Bob. Let me share my screen and we'll get started. Can I get a quick check to make sure everybody can see the slides? Bob? Good. Excellent. Welcome, everybody. My name is Travis Hoppe. I am the Associate Director of Data Science and Analytics at NCHS, part of the CDC. I'm currently on detail at somewhere else, but I am not serving in that capacity. I am serving in the capacity of CDC today, and I will state, because we're talking about generative AI, that generative AI may have been used in these slides and in the creation of it. And I think that's part of the process that we're going to talk about today. So I'm going to tell you a story about implementing generative AI at CDC and some of the barriers that we encountered, some of the barriers that Bob talked about, these good barriers, and some of the ways we kind of got around them in the best ways. So I want to start with the end result. What did we end up with? So as Bob said, we are one of the first agencies to unilaterally deploy ChatGPT to the entire agency. The huge accomplishment by a lot of people here at CDC. We did not do this recklessly, and we did not do this without a lot of forethought and a lot of safeguards in place. But the end result is that all staff at the moment can go on to EDAV, which is kind of our secure enterprise environment, and access what is ChatGPT 3.5 and ChatGPT 4.0. Not only that, they can go on for our data scientists and they can use an API and they can do kind of the data science bits where they can maybe go across electronic health records or death certificates. And we have further goals to kind of bring this to Azure Search, which is a little bit like a RAG, like a retrieval augmented generation piece. That's kind of coming down the line. But this is really cool. This is kind of looking at the technology that swept across the world for the past year or so and saying, we see the potential of this. How can we bring this to CDC? And because this is a talk about managerial stuff, about organizational barriers, I really want to get into it. I want to get into how we got there. And the answer is this word that I just kind of learned a few years ago. It's called policy entrepreneurship. It is kind of looking at the landscape of what's happening in the world and all of the levers you have and looking within your own organization and setting yourself up for success within that organization. So this is a slide of a bunch of things that are on there. I think one of our speakers is going to be very familiar with the NIST AI risk management framework, and she's going to talk a little bit about this, but it's a sequence of events that have been happening for the past 3 to 4 years. This is the landscape in which we were operating as a federal agency. Lots of things to look at, lots of things to take into consideration, but we're one group. How do we set ourselves up to do something that when we see the opportunity for like a chat GPT to come to us, that we can execute on this opportunity? So I want to start off with my center. So I work for the National Center for Health Statistics. And within that center, we've been complying with the AI federal use case inventory. So we had like a nice list ready to go. We've put out things like SANS, which is a non-response detection. We've coded cause of death. We've detected opioid use and misuse. But the really kind of important use of this is that we were already starting to use AI before. And so we were already starting to ask the questions that are in the NIST AI RMF, that were in the White House Blueprint Bill of Rights. And so we were considering how we might use these different technologies in a safe and secure way before ChatGPT came out. And importantly, we were thinking about building things like model cards and standards before we got guidance from our partner agencies. And so we actually built out a long, long time ago NCHS model release standards. So we don't have a lot of model releases out to the public, but for the ones that we do, we kind of have a framework of deciding what sort of things should be done before we release something to the public. And this was actually really useful because when the NIST AI RMF came out, we could do a crosswalk between the two of them. We could take the hard work that the folks at NIST had done and said, okay, we've put thought into this that's contextualized within our own environment. And then NIST is maybe looking for gaps that we didn't consider, and then we can do a one-to-one mapping with this. This was really, really useful kind of as a start. We also kind of looked at, hey, we do want to communicate these things. What is the industry doing for this? And so for us, we looked at model cards, and model cards are kind of like a recipe spreadsheet describing what is in the model that you're releasing. And so part of our release standards, we require you to put out a model card. And so this model card, this is an example of one. It's the non-response detector. It's useful to kind of describe the risk, limitation, and biases, what's in scope and what's out of scope. And you can actually find this on Hugging Face, which is like the GitHub of models. And I say all this not to say for the great work that NCHS has already done, but to say we were starting to do these things and setting ourselves up for when opportunity came around. So this is the policy entrepreneurship part. You have to be ready to execute and set these processes already in place. So it's not just the model release standards. Here at NCHS, we have the whole host of data science resources. We did metadata standards, which are really boring and really, really important. We have work where we're trying to map out social determinants of health. We have kind of like a training and onboarding system. We have even like a publications dashboard. All of this to say is that we were building up the infrastructure internally within our own organization so that we could leverage it when something like this happened. And something very much did happen. There was the release of ChatGPT. We've got the opportunity to go and write an internal white paper when this kind of came out. And this white paper pulled across a whole bunch of people across CDC, people that were working on ethics, people that were epidemiologists, people that were statisticians, and people that were in like cybersecurity. And we said, what could ChatGPT, what could generative AI do for public health? What could it do for us? And this white paper, again, was setting ourselves up for success. It didn't actually get released to the public, but what it did do was set CDC's AI strategy. And not just a strategy on the external part, on kind of the internal piece as well. So our chief data officer, he shared this slide probably about 3-4 months ago at a GovAI, and it's kind of been our North Star of what we've been doing. We have a public-facing strategy we're working on. We stood up a community of practice. We have guidance that CDC has released that is going out to all of government. It's being adapted for that. We have our comms, we have this consultation group, we have our infrastructure investment. But I just want to point out that all of this started because we had set up the infrastructure. We wrote a white paper and said, we think this should be our implementation plan. It didn't end up looking exactly like this, but that was a document in which we could work off of. And that was incredible that we had this. And major props to all the people on that paper, because it turned into these different work streams that ended up being incredibly valuable. These work streams created things like subject matter clearance and subject matter review. The generative AI guidance that I was talking about, it received over 500 comments from internally across all of the different centers and institutes within CDC. And it just kind of shows that if you're going to start doing this, once you start being successful and once you start looking at something that's going to look like policy, even if it's guidance, you will get a lot of attention across the board. And again, this is not by itself. There is generative AI policies, that we were working on, but there's many that other federal agencies were doing. Some of them were a little bit ahead of us. Most of them came out kind of afterwards. Some of them were internal, some of them were external, and journals themselves were putting out these kind of guidances. So once you start a process, you're probably not alone when doing this process. Probably many other agencies and organizations are faced with the same problems that you're doing. We found it very useful to share this data with, or early reports with other organizations. But we also have, I just kind of want to step on the generative AI guidance because I think it was really, really useful and really impactful to get this out there. So the guidance covers like recommendation for generative AI, it covers the scientific integrity pieces, it discusses how you actually use it, and it discusses very specific use cases for public health and the governance of a model. So like we had put this together and this sort of led to the framework of how we were operating with our chatbot that we released. And so again, kind of wrapping it all up, we did release this, but we did a ton of work to get there. And the way we did so was kind of set ourselves up for success by writing white papers internally when we saw the need, setting up communities of practice, and just broadly getting the organization ready to do so. And I want to use my last 2 minutes to say, is this important? Should we have written generative AI guidance? Does it really matter? I just have like 2 slides. Like, this is the end of a long series that NISS and FCSM have put together. It's been a great series, but I love this slide because this is asking ChatGPT for references on monkeypox. Great, cool. You came up with some monkeypox references. One, it created exactly real references that actually exist. And some of these they look like real references. In fact, they look like real CDC authors. In fact, you can even email one of the authors and ask, did you write this? And she's like, no. So again, these sorts of things are kind of obvious to us, probably on this call, but they're not obvious to everybody out there. So it's really important that we write these guidelines. It's really important that we socialize them in a way that the rest of the community can get to. And so I think I'm at time, so I will yield. Bob, back to you.
Thank you very much, Travis. You never fail to entertain and illuminate. So following that act, we have Kevin Tupper. So take it away, Kevin.
Thank you. Appreciate it. Hopefully my screen is being shared. Just give me a quick thumbs up if you see it.
I hear you and I see you. Yep.
Awesome. Great. Thank you. I appreciate it. Travis, loved it. I hope you don't mind if I borrow policy entrepreneurship. Awesome. I love that. I love that approach as opposed to policy stops here. So I love, how do we get to yes? That's the idea of entrepreneurship. So I love it. I'm going to quickly go through talking about how we use generative AI to do all kinds of things, including better stories with statistics. I know I'm not going to be able to get through all the content for sure in given time, so I've left this link up there. You can go to aka.ms better-stories, and it'll have a lot of the content in my presentation. What are we going to talk about and why do stories matter? Patrick Winston, who was an MIT professor, he was an MIT professor. He's no longer with us, but he led a class for many of the incoming students. And one of the things he would remind them is that their success in life is widely dependent on how well they speak, write, and the quality of their ideas. And most people think it's mostly about the quality of ideas, but he said, no, that order is actually reversed, because you can present well bad ideas and they can get traction. And so what we're going to talk about today is how you can use large language models to improve all of those. And we'll start from ideating first, working our way back up to speaking. And we'll do that first by talking about how large language models work. Most people think they're kind of magical. I want to demystify them a bit before we start, so you can see why and how these things that what we call in the industry call hallucinations, which what Travis referred to as those fake citations, how they come about and why you actually want them, in the sense of that's what the ability that the models generate those is what makes the models kind of special. And so we're going to talk really quickly about how the models work. I'll go through some examples of prompts or prompt engineering. There's a whole number of resources in the links that I provided on that aka.ms. And then we'll talk about some of the guidelines and limitations so that those citations don't get through into your presentations. All right, so let's dive in. Most people have seen something like this on the left. It is a ChatGPT conversation that I had fairly early on once GPT-4 was released. And it turns out that GPT isn't just branding. It's actually quite instructive to understand what the model is and how it works. So it's important to understand it, particularly anybody that's in any kind of governance role or responsible AI use role or implementation. You know, I would think this is pretty much a prerequisite to becoming considered AI literate if you don't understand it. So this is really important. The G stands for generative. The whole idea of these models is to generate human-like output. Notice it doesn't say accurate human-like output. It says human-like output. And actually, in a sense, it's very human-like because humans don't always generate accurate output, right? We don't always respond correctly to things. So while the output that comes from those generative AI models, as Travis showed in that last slide, was very natural for the kind of information he was looking for or asking in terms of citations, it was quite plausible, but it wasn't factual. And so that's just something to remember as you're using generative AI, whether you're using an application or going right to the model itself, the responses, while sounding plausible or accurate, aren't always. How do they do that? For this audience, this should be pretty simple. It's just math. It's not real sophisticated. When you think about it, it's not magic. These models were pre-trained on a massive amount of data. If you think about pretty much all the data on the internet that is of reasonable quality, most of it has gone through these large language models in terms of ingestion. And there's all sorts of other processes, but generally think about it. When I was explaining it, one of my government associates said, "Oh, this is kind of like Family Feud." And I said, "Yes, that's exactly right. We've surveyed 7 billion people to this question. The top 5 answers are on the board. And here's the question, what comes next?" And so that's what these models do. That's the transformer part of it, right? That's a machine learning, but it basically is taking all that data, and then it understands the relationships of words to parts of words and what comes two sentences ago versus 3 paragraphs ago. And depending on the size of the model that you're using, you can put in pages of content. And it runs those pages of content through a neural network or a machine learning model to basically say, given what has gone before in context, what should I generate as the next word? And then it puts all of that back through the model again, the entire thing, and says, what comes next and what comes next? And it does that over and over again. So to make it a little bit more concrete, let's say we put into a model, visiting France, you must see ... What happens is the model takes all of its words and says, what's the probability of this coming next? And so it ranks those. And the key is that doesn't always take the most likely. Sometimes it takes the second or third most likely. So for example, if I said visiting France, Paris would be a fairly, these percentages, by the way, are not actual. I just made them up for this example. But Paris would be a pretty high likely probable outcome from that, right? It's a popular tourist destination. It's the capital. Eiffel Tower's there and so forth. The may be a next most likely word to come out of that. For instance, it might generate the Eiffel or the Louvre, expecting some kind of noun phrase to follow, or maybe Notre. So, and of course you would know what would follow that, right? Notre Dame. So it generates those over and over again, and it doesn't select the most likely one. The key though is that's not always going to generate factual output. It's going to generate very human-like output, but it doesn't always generate factual output. And you've got the big red X through top 10 things to do in France. And that's the mistake that most people think, because it generates a lot of things right. People think these GPTs, these large language models like ChatGPT, are knowledge bases, right? They're not fact machines. They're not taking your data and then going to, let me look up the top 10 things to do in France in my list and return that. That's not what happens. It just basically says, given what I have so far, what's the next likely word to come out? And it does it over and over again. So that's how it generates output. So let's talk about how we would use that potentially in storytelling. And I'll start with a demonstration. I'm going to go to Copilot. This is a Microsoft. You can actually use this if you're not. This is my enterprise version, but you could use this if you were using, say, it's now Bing Chat. You probably won't be able to put data in like I'm going to do, but I'm going to base it on some data, and I'm just going to grab a file, and I'm going to grab some GBT data, and I'll show you what this looks like just so you can see what's in there. This is basically a spreadsheet from that I got from USA Facts, through USA Facts from the Bureau of Economic Statistics. And I've just taken this data, which is basically GDP through 2020, and I've thrown it into my Copilot chat. And what I'm going to do is I'm just going to ask a question. I'm going to copy and paste some of this in because my ability to type is inversely proportional to the people that are watching me. And I'm assuming there's a lot of people, so I'll be fast. So let me blow this up a little bit so people can see it. And by the way, I love experimenting with GPTs because you don't know what you're going to get. I do not, literally, most people say don't do a demo if you don't know what the output is. You can't do that, a live demo with a generative pre-trained transformer, because you don't know what you're going to get. But I'm going to ask that question. I'm presenting at an economic conference. I want to give a presentation based on the attached data set and et cetera. So what you're seeing is that data going into the model, and we do a few things behind the scenes with it. With Copilot, you could do the same sorts of things with any kind of large language model, and it's going to generate ideas. GPTs are great. I'm not concerned now about hallucination, quite frankly. At this point, they're great for brainstorming partners. So if you want to generate good quality ideas, give some of your data to GPT and say, hey, what are some ideas that I can talk about this policy? And there's all kinds of other prompts, and we're going to talk a little bit about prompt engineering in a moment. So let's take a look. Let's use this last one here. And now I'm going to say, I'm going to say, excellent. Good presentations begin with good papers. Let's write a paper based on the second track. And I'm going to grab the second track. And I'm just going to put it in here so it knows specifically which one I'm referring to. Now, these models are stateless. If I just said, write a paper on the second one to a model, it doesn't know what I'm talking about. But when you're using when you're using an application, the application owner actually has to do a lot of work to keep track of the state. Because what's happening here is I'm not just sending this prompt on the bottom to the model. You can't see me pointing at it, of course. But I'm not sending that prompt only to the model. I'm sending it to the model with the entire conversation. So it knows the context that I have. And the nice thing about using it inside of applications as opposed to models, a good application here, I've got a citation, and that would actually bring me to my data source. So I said, hey, give me an outline for a paper. And it's basically giving me an outline for a paper based on that second talk track. So again, more generating ideas. And now I'm going to actually have it do some of my work, because I'm not a great writer. I'm a great idea creator. And so what I'm going to do is take this idea and say, okay, it's got an introduction, overview of GDP, its importance, the significance. I'm going to go in and I'm just going to say, thank you. Now I have my outline. Please proceed with a complete draft of the introduction as specified. And so again, generative AI model, it's going to take that context, know what I'm talking about, know the data, and it's going to generate an introduction. And, you know, I happen to know I generate a lot of content with these models. However, I generate it in a way that is far different than you're seeing output here. And so I have a whole series of prompts that tell it the tone, the tenor, my style of writing, how I want the model to generate output. And so what I'm going to do is, thank you, that's great, but I don't write about things like tapestry. I mean, that's just not a word you're going to see come out of me. And so I want to have the model follow my instructions. So I'm going to say, fantastic. Now that I have my outline, please proceed with the complete. Oops, that's a wrong copy. Let me copy this again. That wouldn't get me very far, would it? All right, let's do it again. There we go. Now that I have that. Oh, I'm copying the wrong thing. My bad. Humans make mistakes too. Can you please rewrite the introduction, but with less flair? I want to come across as warm, direct, and plain spoken. So I like what's there, but I want to massage it a little bit. I don't want to be, you know, I'm not going to use words like tapestry. And I could actually get specific, right? I could change into my models, do more of this and do less of this. And so now it's going to write, you see that it's much more plain spoken. It's much more direct. It's much more how I would probably deliver something in terms of a presentation. All right, so now what I'm going to do is, now that it's done that, I'm going to say, great, I now have some writing, and now we're going to talk about speaking. Let's develop a corresponding talk track for the introduction, and please provide suggestions for the slides. Now, this is what's really fascinating to me. If this follows the example that I ran through before while I was testing this, it's going to generate far more than I want, and it's not going to respond to that prompt really well. So while it's thinking, we'll wait for it to come out with a response. I'm not saying stop responding yet. There we go. Combing through the document. It may go out to some external sources. We'll see what it generates. Okay, that's what I was hoping it's going to do. You know, that's actually better. Before it gave me like 12 slides, and I'm like, 12 slides with one sentence each, that's just too much. But this is even a little bit too much for me. I want an introduction. So I'm going to respond, and I'm going to, again, guide the model. And you'll notice this is a collaborative back and forth. This is not just the model generating output. All right, so I'm working with the model, and I'm just going to say, that's not helpful. The introduction should have far fewer slides. And I'm basically going to say, hey, I want a one slide introduction and provide the talk track for that slide. So it's going to take that, and if it follows the instructions well enough, it's going to condense it to one slide. I wanted it short, concise, boom, for the introduction. So that's just an example of how you can use these generative pre-trained transformers, these LLMs. It doesn't have to be Copilot. It could be your own Azure OpenAI. It could be one of the other commercial models if you're using a different cloud provider. And so the models all work similarly. What you're going to find is, though, that they may function different for the same prompt. Different models will have different behaviors. We'll talk about that in a second, but Travis covered a little bit with their model catalog. The key thing for me, you see the prompting tips up there. The way I think about it is, when I was in 8th grade, one of the subjects we had to do was take a video of somebody following our instructions and we had two choices: chew bubble gum and blow a bubble, or tie your shoe. And you would think those things are easy to instruct somebody to do. But we would write those instructions down, and then we videoed students following our instructions. And you could imagine, put the gum in your mouth. Well, you never told me to unwrap it. And so people are putting gum in their mouth with the bubble gum wrapper on it. And it said, press against the chew and press against the roof of your mouth. So the person chews, sticks their thumb in their finger and pushes against the roof of their mouth. That's the kind of silliness that you might realize you have to provide clarity for with a model. Because if you give those kinds of instructions to a model, it will follow those kinds of instructions on your output. And that's all what these prompting tips are about. And in the list, I have on the links provided, there's a whole 2 or 3 articles on some really good articles on prompt engineering that you'll find. In terms of guidelines and limitations, some things that you want to think about. Everything that I did here was all on public data. If you're using public data, no problem in government using any of the open source models, the models that are available publicly through web URLs. Based on your agency's policies, of course, follow your own agency's policies and guidelines. Ultimately, you're going to want to use these models in your cloud provider, where you're much more likely to have privacy and guarantees and SLAs for security, compliance, and those sorts of things. As I mentioned before, you're going to be careful about the model variations, because models respond differently based on the kind of model, so that you won't get the same model. Travis talked about a model catalog. We have a lot of the Hugging Face models also running inside of Azure OpenAI, so you can run them inside of your model, and then you could click on a model and see the model card with sample outputs, what it's good at, what it's not good at, those sorts of things. That's all available as well. And then the last thing I want to talk about is hallucinations. That's that idea where the model basically just makes something up that sounds real good. This is still an emerging concept. Well, the hallucinations aren't. Dealing with hallucinations and evaluating and solving for them is still rapidly emerging. In Azure, we have something called the Content Safety Studio, and actually a new feature that just came out is groundedness detection. So you'll want to provide the model with data sources, and you can actually then check again the output against the data and validate so that a human doesn't have to do it. So it's one thing for us to use something like this interactively as an individual. It's a whole nother thing to do it at scale, and then have it more running in an automated pipeline so that you're solving different kinds of problems with agents and other kinds of tools. All right, so I think I've covered everything I want. Again, feel free to connect or outreach if you have any questions on the content, and looking forward to a discussion with everybody else, and I'll turn it over back to you, Bob.
Thank you very much, Kevin. It was, I thought it was really fun to watch all that kind of play out in real time on the screen, and also I thought there were some really important little pieces in that presentation about how to focus on the strengths of generative AI. All right, moving to our next speaker, Stephanie.
Okay, good. All right, so let's start from the beginning. Kevin, I loved your input on prompt engineering. I won't get to spend a ton of time on that today, so I'm glad you covered that. And the neural networks, those are huge over here at the Census Bureau right now. So just to touch a little bit, I am going to touch on a couple of projects that are using large language models, machine learning, AI, whatever the word you want to use is. Really around the Census Bureau, we have pretty significant portfolio of projects and programs that are going through these types of models as we speak. However, inside the Census Bureau, there is quite a bit of governance, policies covering these, how we share sandboxes, and also a lot about oversight, what we're using, what technologies we're using, make sure we're ensuring the data, that we're not exposing anything we shouldn't be exposing inside the Census Bureau. From all of that, we are doing slides, presentations, white papers to kind of talk about the things that we're learning. And we are sharing this information not only in sessions like this, but with other statistical agencies in the US and also abroad. I would say one of the big things that I would touch on is the Census Bureau has been a largely SAS environment for many, many decades, moving to a Python-based environment. So some of what you're going to see today in some of this portfolio is really our transition. And Kevin, a lot of that has come through prompt engineering, to say the least. So the first project I'm going to touch on is what I would say is was one of our original projects, a little slower into the environment for a statistical agency into using models. The business formation statistics was a project where we take administrative records from the IRS from SS4 forms, and we basically take that information, put out a statistical product that was really heavily used during the COVID pandemic. What kind of businesses are being formed at this point in time? And what we saw was this huge inflection, this surge of businesses in the SS4 forms. Unfortunately, a lot of what we were doing was manually done. It was being manually coded. So basically, the first thing we did was come in to play with, we did this a lot of manual type approach. Then we came in with some linear probit models or probability model. And we really started rerunning these applications, looking at their detailed characteristics and manually choosing those. We very quickly started to pivot during COVID to this more of a machine learning approach. How can we improve and automate the definitions? So we used a number of classifiers and other items to really look at accuracy and scalability of the models. How could we do it? How fast could we do it? Because the business were surging faster than we could actually assign NAICS to them. So we started generating models based on important features like NAICS codes and really looking at how could we make the models better. So in a very, very short period of time, as you'll see on this slide, we really got to looking at improving the model, but how could we get to new? So what was coming in new, what we saw was a real change in the retail sector. So what was happening, moving from brick and mortar to more online. We also saw a lot in services. So there was a huge peak in services at that point in time. And then engineering, this was right around the time of the infrastructure bills. So seeing a lot of change there as well. The next one that I'm going to spend a little bit of time on is our entire construction reengineering program, which is really bringing in a lot of this, plus us building models on our own around the principal federal economic indicators. The Census Bureau is responsible for 13 principal federal economic indicators. So if you read the headlines, what's the trade deficit, new home sales, retail sales, all of that comes from the US Census Bureau. It's all embargoed data, and it's released once a month or once a quarter, depending on the indicator. In the construction world, which is where I'm going to talk about, we have three indicators: construction spending, new residential construction, which a lot of people see in the headlines as housing starts, and new residential sales, known as new home sales. As an indicator, these are gold standards. They move global markets. They're embargoed till 8:30 or 10 o'clock in the morning. So it was really, really important that we started looking at large language models and things of this nature, going to satellite imagery. How do we ensure that the data that we put out that moves those financial markets it's sound statistically? So we embarked on pursuing new data sources. So really looking at alternative data, new technology. Our methodology was 50 plus years old, and all of the data science techniques that we could use. So I am going to show you next. We had basically conducted the construction progress reporting survey, which gives total value of construction put in place. And we had done this since the 1960s, all the same way. We relied really, really, really heavily on drawing a sample each month from the frame of construction projects provided by Dodge Data and Analytics to the Census Bureau. The classification of those projects by the vendor isn't super detailed, and it really doesn't meet the needs or timeliness of an indicator. We really need to have the data within 10 days of the close of the previous month. So there aren't a lot of data sources out there who turn data around quite as fast as the Census Bureau does. This solution had really been a problem for us because, again, we had analysts reviewing 1,400 projects in just a few days, reading the descriptions and basically manual assigning classification codes. This really introduced biases and inefficiencies because there was huge cost increases, constraining the sampling rates, and then potential quality on the indicator. The good part was the text fields and all of the values that the vendor provides to us really gave us an insight to how we could use and build a solution that would leverage this heavy text and give us machine learning to predict classification codes. We did several months of development and validation. We were able to start beginning to use this solution in production earlier in 2024. The models that we created are classifying over half of the newly sampled projects each month with a prediction confidence of no less than 80%. So this was huge for us. And let me give you a little insight to this. So basically, as we started down in this environment, we relied heavily in our survey of construction as well to measure the new housing starts. So this is when we start to see excavation. This is when we start to see ground movement. Currently, we send people out into the field to look for this ground movement. Is there an excavation? Is there a start? Is it complete? This operation limits us to about 900 sample units a month. So what we started to do was use satellite imagery. But basically what we started to find in that sampling imagery was that we really had to start taking apart the images. The low res images did not work for us. We had to go to high res tipping and queuing in order to get the information we needed to begin the segmentation that you see here in these models. So basically, as you look at this, we took individual pixels and shapefiles, and we basically hand taught a model how to do this, how to take this, these images apart, 2,000 of them. Every little pixel you see here in this image, we took apart and hand labeled. There's about 2,000 images that we did to train it on what it sees. What you see here is the teal color is a foundation. What you see is the gray is really an excavation space. The purple ones are framed locations, and blue means finished roofs. So those are finished. So in order for us to start to train our models when the satellite imagery came in, from what you see on the left to what you see on the right to what we can include in our monthly statistics to the American public, was really training 2,000 images to now what we're turning on in the entire United States. Now, I will say one thing that kind of threw the model here was when you get into Florida and locations like that, the roof structure is brown in some instances. So we really had to really take the models apart in different areas of the country and train it even more so that it wasn't misclassifying these unit types. Next, we'll talk about predicting the construction pieces. So again, we thought we could be really, really efficient with the use of parcel data, with the use of permit data. The unfortunate part for us is the parcels and the permit data don't keep up to speed with 10 days from the close of the month. So really it became the Census Bureau who had to figure out how to start taking this imagery apart and starting to determine first, when you look at this image, is it residential construction? Because some of our indicators are around residential versus non-residential construction. As you can see on the left, we started to get really, really good based on the time we got away from the collection of the data. So for instance, let's say the parcel data and the building permit data caught up. The image on the left, we could get relatively quickly. However, in the time we needed, we started to have to actually set this up and code each and every one of these images. So another about 3,000 images we started to classify about what is residential versus non-residential construction. And then we started really segmenting models that can predict the zoning or the building type. And with this training data, which we thought was relatively small, we've actually been relatively successful. We've labeled, like I said, about 3,000 images here. We've interactively trained the models. And from that, in the 12,000 predictions we've done this month, we have an overall F1 score of about 75%. So we're looking at this along with the data of sending humans out into the field. So how accurate is that information? What this will do is ease our collection costs. We can really increase the number of sampling units, really reducing the error that we see in the current data that we release every month. And the other parts that I would say about from this perspective, when you look at the image here, if you can see in the image, where you see the purple here, it's done. If you see it, it's like a little bit of purple, a little bit of teal. We are still taking this image apart from this image right here. So we are constantly taking these smaller pieces that we do and interlaying them to way larger parcels of land, and really starting to segment and take apart, as you can see to the right, which are home locations, what are going to become subdivisions. So we're constantly flying the satellite to see where they are in excavation. Is there a roof on the location yet? And is it completely finished? Is the roof finished? So a lot going on here with models, especially neural networks. And really, most of the models that have been built around this weren't things that we could use necessarily from the outside space because of the timing constraints we have. We really thought third-party data would be a great input to the model, but it has turned out to not actually be as reflective as we had hoped. So a lot of time spent on these two projects, but these are just two of what's in our current portfolio. Baba, I will share the time back to you.
Thank you, Stephanie. That was a fantastic presentation, of course. And for those who don't know, you spent a little time at the beginning talking about PFEIs, and at the federal level, we really only have like two classes of federal statistics. We have the principal federal economic indicators and everything else. So the PFEIs have a whole separate set of quality requirements and standards, and they're monitored very closely. You can imagine housing starts is enormously policy relevant. So, you know, when we talked at the beginning about risk aversion barriers, you know, if this is the sort of thing that you can get done at the Census Bureau on a PFEI, it's really an inspiring accomplishment. So thank you for sharing that with us. And I will turn things over now to our final speaker, Reba.
Thank you. And I think Megan is actually going to share my slides. Thank you. Thanks so much. Yeah, my name is Reva Schwartz. I'm a research scientist here at NIST, not NISS, the National Institute of Standards and Technology. I'm in the Trustworthy and Responsible AI program, and our team really focuses on risks and related impacts of AI. So we've heard a lot today, mostly about performance of the model or the system or what it's capable of doing. And I'm really here to talk about the AI risk management framework and describe how it can be used to build up a risk-aware culture within an organization, including here in the government, so that those organizations can design, develop, deploy, or use AI technology safely. Next slide, please. Thank you. So some quick scene setting. Certainly NIST had been working in the area of trustworthy AI prior to the framework, or when we were asked to do the framework. But our journey really began in 2021 when Congress mandated us to produce a risk-based framework for managing the risks posed by AI to individuals, communities, society, organizations, the planet, pretty much everything. So over 18 months, through 3 documents for public comment, 3 workshops, and hundreds of listening sessions, we ended up working with more than 240 organizations in a multi-stakeholder, open and transparent process to deliver the framework in January 2023. So more than a year now. Next slide. So what is the framework? It is voluntary, so it is not regulation, it is not required in any way, and there is nothing to comply with. It is a flexible resource. And what it does is help organizations build up their risk-aware culture so they can move from kind of high-level principles about trustworthy AI or responsible AI, which a lot of people use those terms but don't really know how to put this into place. So, and I want to just take a second here to throw out a definition. We're really fond of our definitions and terminology here at NIST. What we mean by risk is the composite measure of an event's probability of occurring and the magnitude or degree of consequence should that event happen. This means that risks can result in impacts that can be positive or negative, or both, or in opportunities or threats. So we tend to, when we hear risk, we tend to hear like, oh no, it's always negative. negative. But in fact, risks can bring opportunities. I think we've kind of changed our perspective on that over time as a culture. So for AI, there's obviously tremendous potential for positive impacts, but we can't really reap those benefits without managing the risks. So how do we do this? How do we manage the risks in the framework? The framework provides concrete, actionable recommendations that organizations can choose from based on, their applications that they're building, their context of use, their specific risk tolerance. And it can be used by any AI actor across all stages of the AI lifecycle or in use and all parts of an organization. Next slide, please. So it does this through a few key approaches, which is really the focus of the conversation today. But first and foremost, the AI risk management framework can be most effective for organizations because it's not about following a checklist. It's about adapting internal organizational culture and the related practices to better anticipate, consider, and measure risks. And we do this, and we provide a method for doing this from a socio-technical lens. So what does that mean? AI systems, like most software, are products of complex and interacting human, organizational, and technical factors. We tend to really stay focused on the stuff on the left side of the slide, which is the technology, the circuitry. But of course, humans are all along the life cycle making these decisions, and there's many decisions along the way before tech is deployed or how it's used, and making those decisions in an informed way using risk-aware knowledge from throughout the organization can improve the stability of the organization, the performance of the technology, build trust with our stakeholders, and keep us away from these pitfalls. So the risks and negative impacts are not really about just about whether the technology works. It's really much more about how the technology is used, who uses it, who is impacted, both positively and negatively, and then the conditions under which those impacts happen. Impacts don't actually happen, in the model. They happen out here in the real world. So we're moving from, when we talk about AI risk, we're moving from a focus on performance towards one on risks and the related impacts. Again, both positive and negative from a socio-technical framing. And getting an organization equipped to do that does definitely take a number of steps. Next slide. So this is a slide of the AI risk management framework core. It is where the risk management activities are organized. There are 4 of these functions, and they're designed to move organizations from general risk management principles to specific practices. Each of those 4 functions is broken down into categories and subcategories. We have a total of 72 subcategories. It's a lot, but that gives everyone 72 actual actionable outcomes that they can build towards on their path to creating a risk-aware culture and delivering trustworthy AI. And certainly, it's important to note, again, because this is not required, any organization can pick whatever they want from those 72. They can do 5, they can do 20, they can do all 72. These functions in their subcategories tend to, we say you can do them in any order, but we do tend to typically see them happening in a govern, map, measure, and manage. At a really high level, the govern function is where organizations kind of set up their policies, procedures, and their structure within the org that align their operations with societal values, with their organization's values, and any existing legal and regulatory requirements. The map function is where AI actors across the organization can build up their skill sets and use their skill sets for anticipating risk, again, from a positive and negative perspective, including how AI systems, this is pretty important, right, might be used in ways that were not part of the original expectation. Generative AI is multi-purpose. It's going to be used all sorts of ways that people didn't, and repurposed in all sorts of ways that people are not anticipating. So how do we build up internal capacity for anticipating that? And then the measure function. This is where organizations are setting up their repeatable and scalable TEV practices. This is test, evaluation, validation, and verification, so they can track these risks across the life cycle. And then finally, the manage function. This is where hopefully organizations are preventing risks that have been mapped and measured in the earlier parts of the core. And then if they do materialize, this process gives them structure and practices for how to how to respond to them using policies that were built up in the govern function. So you can see how these functions all connect. Next slide. So the goal here is to help organizations build up a trustworthy AI within a culture of responsible practice and use. So if you're an organization that designs and develops technology, you can use the map and measure function to better understand, risks and impacts, other forms of limitations, how all of that stuff might manifest, and then track all of that information across the framework. If you're an organization that deploys or uses trustworthy AI or just AI, you can use the manage function to do that in a responsible manner. And then, of course, for all of our evaluators out here in the federal government, you can use the framework to build up new measurement methods to move beyond a performance-based focus to consider the risks and impacts of the technology in the real world. So let's talk, next slide. Let's take a minute and talk about what is trustworthy AI. This slide shows the 7 trustworthy characteristics that NIST identified as necessary for delivering trustworthy AI. And it looks kind of obvious and simple when you have it all right there in front of you. But I will note that for many, many years, people just kind of said trustworthy AI, but that meant different things to different people. And if you are a project manager or a developer or a systems engineer, anybody who's trying to get that out the door, it really wasn't clear what you should actually do to put these concepts such as security or fairness or transparency into practice to actually make your systems safe, transparent, fair. And so with these trustworthy characteristics, organizations have actionable and measurable options for doing that. At the bottom, I'm just going to talk about the foundational piece, which is validity and reliability. So you can deliver technology and AI that's fair or private, but if it isn't valid and reliable, it can't maintain those levels of fair or private performance over time. So validity is really all about that the system has been demonstrated to do what it claims to do. It's a higher bar than whether it's delivering accurate content. Next slide, please. So switching gears a little bit to just kind of focus on risk management and why it's so difficult. Risk is really hard to measure. The tools, as we've been saying, the tools that we currently have are much more about performance rather than risks and impacts. So we don't necessarily even have the right tools for the job right now. And that's a lot of what NIST is working on next. Tolerances vary. What's deemed as high risk in one organization isn't the same as in others, and those organizations might be using, or having to deal with regulatory or legal requirements. Risks have to be prioritized. Again, with the rise of generative AI and multi-purpose use technology such as generative AI, it's really difficult to anticipate how it can be used. So the map function is pretty valid right here. All of this information about risks have to be integrated. But the visibility across the AI lifecycle is really limited. So the skills for identifying or contextualizing risks are really, it cannot be overstated here. This is why the framework was designed to be implemented reflecting diverse and multidisciplinary perspectives within the organization. If everyone has the same set of skills and viewpoints, we can't comprehensively consider, again, not just the negative risks, but also the positive risks that can help us leverage those opportunities. Next slide. So talking about the life cycle, this is where things get operationalized. You can see that we have people in the planet at the center, and we have measurement and monitoring all around the life cycle. It's really, I think, you can think of the life cycle as the culture that helps bring trustworthy AI practice to life. Each part of the life cycle, though, comes with its own actors and activities. And if you look at the framework, figure 3 goes into great detail about who these actors are, what their tasks could be. But they're each operating, under varying contexts, and they have different risk perspectives. So you could have a developer of a pre-trained model who has a very specific vantage point of risk at their stage of the life cycle, and they hand it over to the deployer, who has their own vantage point and perspective of risk. And then, of course, a member of the public who uses it, reuses it, misuses it, repurposes the AI in ways that nobody designed it for. So all of these actors have to work together to anticipate the harms. And this is really where a risk-aware culture comes into play. Next slide. So just a quick example here. There are a billion different ways that you can put, maybe not a billion, different ways that you can put each of these pieces together to help show the flexibility of the framework. Again, pick 10, 20 of these subcategories, but at a really high level, some key themes for, interdisciplinarity is really important to get better at identifying risk. The need for TEV, you saw that across the entire life cycle, to measure risk in a transparent and repeatable manner. Participatory methods to help improve those measurement approaches. This is where we're bringing in external voices to help consider risk from outside of the life cycle perspective. What are the limitations that we're not thinking of? And then organizational buy-in and commitment, because without that, no set of practices or methods or any risk management that we put into place can be sustained without that. And then finally, last slide. Just a word about our playbook. This is the AI Risk Management Framework playbook. It is on our AI Resource Center at airc.nis.gov. We developed the playbook to help AI Risk Management Framework adopters know how they can actually meet the outcomes in the framework core. So we have these outcomes. How do people get there? So all of that's, we have a lot of examples, tons of references. I think it's more than 200 pages. We're not meant to read it from front to back. We also have a glossary in there. So yeah, I'll leave it there, Bob. Thanks.
Thank you, Reva. That was fantastic. And I think moving from risk averse to risk aware is really a common thread that's run through not just this whole set of talks, but also through the entire AI webinar series that we've been hosting here. So I think that was a fantastic final presentation here to cap all of them off. And we still have some time here for questions. I have a good, challenging set of questions for our panel members here, so I hope folks stick around for the discussion. And I'm going to lob the first one at Travis. So in your presentation, you talked about your work at CDC and helping the organization to build policies and then also get resources, a specific tool in ChatGPT. So could you talk a little bit about how once you have those things in place at an organization, how are you connecting them to staff so that they're actually used in support of the mission?
Yeah, and thank you. We can kind of bring all the presentations together with the answer to that question. Some of these things were said during other parts of the presentation, things that are common problems across federal agencies. We heard some of these things like lack of access to data, lack of the ability to understand the programming languages that are used. We heard the SAS to Python. That seems like a little thing, but for agencies who are still stuck in one language to another, that's a big thing. Is that an AI thing? Not really, but most of the integration challenges are really not AI things in the first place. There's a thing that if you're in the government and I say this word, you're gonna make a face, and that's an ATO. And navigating an ATO for bringing an authority to operate for those who aren't in it is a really complex challenge, and it's really hard for something that's a new technology that we don't have a framework or a box for. In some ways, when we were looking for early on access to these kind of cloud models, it's easier to get enterprise access than it is to spend $10 on a server. And so this sort of integration challenges is really difficult. I'll note that the risk management framework is amazing, and it's big and it's really dense. And so if you're somebody like me whose job is to parse this out and disseminate that out to other people, that's great. It has all the information you need. If you're just a manager down the chain who's working on a million different projects, it's hard to understand what pieces you need to pull out. Riva mentioned some of those things that we should be looking at, but where do you look if you just heard about it in a seminar today? And so these connection points, this is common across all the different agencies. So to answer your second question, Bob, how do we fix that? How do we approach doing these things? I don't know. Let's have a seminar where we talk about these things together and we talk about bringing these pieces together, right? The awareness of these things, and not just the awareness that things like the NIST RMF works or that CDC has released a chatbot, but knowing that these people exist within the agencies or knowing that these resources exist is the huge first step. And not just knowing they exist, knowing what's in them and how to call upon them is a huge piece of that. And I will say for other things, there are communities of practice that exist. This is kind of an external event. This is NISS and FCSM, but the GSA has an AI community of practice. CDC has their own. HHS has their own. And these organizing groups are really good to ask kind of the lower level questions that would be hard to get to. Over.
Thank you, Travis. I will lob the next question maybe at Riva. So either through your experience on this framework or other similar NIST products, because this is kind of NIST bread and butter, right, is putting together guidance and frameworks for federal agencies. So in your experience, how do those frameworks help people at the agencies who are more forward-leaning break through maybe less helpful barriers like fear of new technology or fear of breaking something that's working okay currently?
Yeah, I mean, I think it all has to be targeted to the right part of the audience. And I think, a lot of times, I know I used to be a practitioner, and a lot of times the issue for me when technology was developed, that I wasn't really necessarily, and actually that's not really a case because I worked with so many amazing researchers, but it does happen, right? That you get technology designed and developed for you and just handed to you. And a lot of times, so this kind of human-centered, user-centered, socio-technical thinking and approach to risk would take that into consideration and make sure that we're, participatory approaches, that we're including the end users so that they're not afraid of using this technology, that it doesn't just show up on their desktop and now they have to let go of the process that they've had for a decade or the tools that they've relied on for however many years, that all of this takes it into consideration. So we're not just thinking about technology in this isolation, in this isolated way. We're connecting it to across the entire org. All of that helps with building trust, getting buy-in, and getting people to have their say.
Thank you, Riva. Yeah, I totally agree that there's a heavy trust component here too, and that's also a nice part of what NIST does, right? It's a very trusted federal partner. I think it has a lot of authority and weight when they put out guidance like this, can really help agencies. So I appreciate that you mentioned trust. Okay, next question is for Kevin. So Kevin, I noticed on one of your early slides, I jotted a quick note here, is you had a quote that, your effectiveness is based on your ability to speak, write, and the quality of your ideas in that order. And I think that can be a scary idea for especially federal statisticians. We think we have the best, right? We're the purveyors of truth. And to think that that's where the quality of ideas lands is a little scary. And you're talking about storytelling with data and storytelling with statistics, which isn't by its nature always completely objective. So I'm curious, there are cases when statistics can be distorted or misrepresented to fit a certain narrative. That's always a risk of storytelling. And I'm wondering if you have any thoughts on whether there are unique or different risks here when it comes to generative AI, or if this is just the same issues that we've always had with storytelling with data.
I do have some thoughts, and I'll say these thoughts are my thoughts, not Microsoft's, just so even though I work for Microsoft, I'll have to caveat some of this with some of my own thoughts. Particularly, I'm really passionate about helping government bring forward and moving forward into generative AI. In fact, my personal mission is entering the AI era together. And together being the operative word, because we've just come through a period of storytelling with multiple constituents looking at COVID data and coming with different interpretations, right? So everybody was arguing their version of truth, and I'm not going to get into one side or another side. It's not the point. The point is that we all looked at the same data, and everyone often brings our own biases to the data. So we see the world as we are more so than as the world necessarily is. And so one of the things that you asked, particularly about using generative AI, there are two what I call superpowers in generative AI and the ability in these large language models. It can help you become a really good storyteller. Like if you learn how to prompt the data, learn how to prompt the models with data. Sam Altman, who's one of the founders of OpenAI, has talked about that these are going to become incredible persuaders. So the models will have the ability to persuade really, really well. The good thing about that also is that I can actually fact check myself in a sense, or find holes in my own arguments to say, hey, what's a reasonable argument against the views that I have? And there was just a paper, unfortunately, I should have grabbed the research to it, but these models actually can help people become more grounded in reality versus going off to some of the more fanciful interpretations of data that we might have based on our views. So I think you were asking about biases and things like that, and the bringing our biases to the data, and are we moving forward ungrounded? I think this is a way that we can, if we're willing to interact more so with the models, as you saw me interacting with our own data sets, we can actually help ourselves become a little bit more balanced. And then the other thing I'd like to say in this era, particularly because you are absolutely right, stories are more subjective. We don't necessarily present facts all the time. We present stories, because stories is how we understand the world around us. And what I would just encourage all of us to do is, we're listening to stories that might seem very persuasive, that we also might disagree with, is to assume good intentions of the other person. And quite honestly, we have not done that really well over the last few years. So this would be about realizing, hey, we're all in the same country, we're all on one side, particularly as we're trying to move forward with government. And if we can have more discussion as opposed to more not listening, less active listening, and more, no, but my truth is this, that sort of thing, I think that will help well. And if anybody has used these models, you'll notice the models actually specifically the large language models produced by some of the bigger companies, do a good job at trying to avoid the harder edges that we might have when we're an evangelist per se. Now, I've often been checked by the model, says, whoa, slow your roll, Kevin. As I'm developing talks, for instance, because my job is to evangelize this technology. And so to Riva's point, it comes back and says, well, you might want to consider these risks as well, right? So those are all kinds of things that we can do better in our storytelling, I think.
Thank you, Kevin. That was a tough question, and I agree with your self-assessment that you fed to the model that your writing style is clear and direct. I think it's something you said like that, but that was you embodied that there. So thank you. I appreciate you tackling that question. So I have one question for Stephanie, and then it looks like we'll have time to lob a couple maybe to the whole panel. But Stephanie, you presented on deploying a very innovative and experimental approach to what I would consider, a long-standing gold standard principal federal economic indicator, right? So I'm curious if you could talk about kind of that, how you were able to overcome barriers in that specific use case, and whether the kinds of frameworks or policy guidance that other presenters talked about were brought to bear on that.
Absolutely. So great question. So you're right. In the construction world, those three programs are all principal federal economic indicators. They're all heavily watched. But we had this huge ask from our stakeholders. We need data. We need more data. We need more concentrated data, make it timelier, make it more granular. And the answer wasn't putting more surveys in the field or being able to put more field people in the field. There just wasn't funding. It was a budget constraint for that. What were the opportunities in third-party data? And so while there is a ton of third-party data out there in the commercial sector around construction, it's used every day. It doesn't meet the timely constraints of an indicator. So within that 10 days of the month. So it's really important that we not only figured out how to do this, but we actually had a scientific panel assigned to us with geospatial engineers who have looked at every aspect of models we've built, because many of them have been built with scientists inside the Census Bureau because they didn't exist, or we could borrow from some. And so it wasn't just getting the leadership in the Census Bureau to say, yeah, this is a great idea, it's innovative, but also working with stakeholders, not only in the federal sector who were data users, but also in the commercial sector. So AGA, many other organizations use our data all the time, Home Builders Association. So it was really going out, and we've changed definitions that have been on the books for over 50 years. And could they buy into those changes? So this wasn't just risk aversion in the Census Bureau. This was risk aversion from many other federal and state agencies, from the commercial sector. Did people buy in? A scientific community of folks assigned to us that we still work with on a daily basis, and then also working with statistical agencies globally to say, how are you doing these things? Stats Canada's been a big one for us. We've worked very closely with them, the Australian Bureau of Statistics, just many, many places. So it wasn't just about internal. And I loved what Reva said a little bit about the risk, right? Being risk averse, being risk aware, right? And making people feel comfortable with the statistics we're putting out. We're also using them in an experimental model first, so that our users get to use the experimental products first, hand in hand with what we've considered our gold standard for many years. So there's this ability to give feedback. So nothing we've done has been drastic and immediate. It has followed a very, what I would say is risk aware, very communication heavy platform to everyone to get that input as we've gone through the process. And I love talking about the actors a little bit, because it's true, whether it's been construction, re-engineering, or now we're working with large US companies to move away from surveys and move more into providing their data in direct feeds. We're using large language models to take that data apart and actually be able to quickly assign metadata and things to it. So in doing those things, it's been really, really important as we've started these to make sure that all the actors understand their roles. And there has been some anxiety, I would say, around people where we're making major change to how they do their work every day, whether it's a field representative who's concerned, how does my world work now in the future state, to our data users, to even our analysts, where we're making major organizational change using these models, this machine learning. So it's really, as a leadership team, is really being a part of the process with them, communicating, saying it's okay, and helping them move through that process. It's been huge in the economic directorate at Census recently.
Thank you, Stephanie. That's great. And you talked about external review, working with stakeholders, collaboration across other international partners. And I just want to say, from my experience at OMB, I see this a lot, where there's seldom anything that's so new and different that we can't kind of go to the well of how to make change in general, that we can't apply it in the same way. So so that was very interesting, and thank you much for that answer. I think we have time for one question that I'll throw to the group before we close out in our last 5 minutes, which is often with new technology, new processes, there are early adopters at agencies who take these things on. And there's a phrase in ecology, they say that a species may be endangered but locally abundant, and I find that's true for early adopters and federal agencies too. So when there are kind of these pockets of forward-leaning folks who are working on this, who should they be thinking of bringing in, like intentionally reaching out to? Who should be in the room as AI is being developed and also as it's being deployed? Travis, with a fat hand.
Sure, I can start this off, and I'm sure others have comments. When you're thinking about doing this, obviously there's like internal considerations, like make sure your cybersecurity folks are in there, right? From like a general deployment of software thing. You should think of your technologists and non-technologists. You should think of your end users. If you're deploying this to your organization, you should think of your labor unions, because this is going to affect the staff that are on there. Like, you should think of that whole organization. I will also add that if this technology is going out to the public, if it's not an administrative thing, if it's not helping you process one coding scheme to another coding scheme, and the public is going to be interacting with it, there is a great memorandum that OMB just dropped about AI that we can maybe put in the chat that outlines what happens when you have AI that is safety or rights impacting. And both that and the NISS RMF, I think it's MAP 5.2, I tried to look it up ahead of time, that says that you should bring in affected groups. So whatever that means, it is a contextual answer. Those people need to be brought in both before you start doing it and after you start doing it in the test and evaluation phase. Riva, over to you.
Yeah, exactly. I mean, you took the words. All right. So two groups. So first of all, we talk a lot about the need, like this, that technology cannot be built in a vacuum. This is why I'm going to keep coming back to figure 3 in the framework. Like, all these different AI actors are right there in figure 3, where and early and often you have got to, the users cannot be an afterthought, the communities cannot be an afterthought. Sometimes it isn't feasible to do large scale participatory engagement. That's totally understandable, but there has to be some mechanism to bring in external viewpoints that could be different types of subject matter experts. But the real reason here is like we're really big on interdisciplinary approaches here, which is the thing that everybody talks about, but nobody really knows how to do, because it's really, really hard for people to talk over the silos. But the benefit is huge, because if everybody is talking, if I have one group of, disciplines, if it's all engineers or all technologists, we all understand the same thing. And we get in these like blind spots, if you will, and open to pitfalls. The more we bring different perspectives in different disciplines across the organization, even if they're not technologists, so end users, and the federal government has possibly the largest group of specialized experts in the country working. They can be brought in and leveraged in those types of activities. Thank you.
Thank you very much. And one quick second before I go to Kevin, if there is a chat, I don't see one, but if there is, if someone could drop a link to the CNStat AI Day coming up in there too, I think the folks online would be interested in that. Kevin, close us out with some final thoughts here.
Just one last thought to add to what Riva was saying, as well as the interdisciplinary teams, not necessarily someone to bring to the table in terms of the deployment, but for the process of deployment is remediation, because there are going to be cases where we deploy acceptably faulty AI agents solutions, right? Where the risk is acceptable, the risk of a false positive or false negative is acceptable. That doesn't mean it doesn't need to be remediated. So you cannot deploy an AI solution, whether it's even internal or public, without knowing how do I provide either redress if it's necessary, or fix broken solutions. So that's just something that you need to think about upfront with these solutions, because it's probabilistic. Tuesday is not necessarily Tuesday when it's an AI model.
All right. On that note, still optimistic note, I want to thank, of course, all of our fantastic panelists today. Thank NISS for collaboration with FCSM in producing these. Thank my colleagues on the FCSM who put a lot of time and effort and energy into organizing these with the folks at NISS. And also, again, thank the sponsors of the webinar series. And of course, thank you all for joining us. And we hope to see you at the CNStat AI Day also, which will continue this conversation. All right. Thank you all.
Thank you.
Thanks, everyone.